In the previous video, we have already seen the formulas regarding basic properties of soil, consolidation and shear strength. Now in this video, we shall see the formulas from effective stress principle, permeability and seepage and stress distribution. Now let's get into it. Now let's start with the effective stress principle. So effective stress is calculated by using this formula. Sigma bar is equal to sigma minus u. And what is sigma here? Sigma is total stress and total stress is given by summation of gamma into Z, and this gamma is unit weight. It can be saturated or dry unit weight or bulk unit weight depending on the condition prevailing, and Z is the total height of the soil strata, and U is the pore pressure, and pore pressure will be given by gamma W into H. H is the height of water table and gamma W is the unit weight of water, that is nothing but 9.81 kilonewton per meter square, and sigma minus U gives the answer for effective stress. And now we shall see capillarity also. Hc is equal to 4t cos alpha divided by gamma wd. And what is Hc here? It can be capillary rise or capillary fall. And capital T is nothing but the surface tension. And we know gamma w. And what is d? D is nothing but the diameter of capillary tube. And it is a generalized formula. H is equal to 0.3084 divided by d in centimeter at 4 degrees Celsius. And at 20 degrees Celsius, what is Hc value? Hc is 0.2975 divided by d in centimeter. When we use only water is the standard liquid. When we want to use this to generalized formula, at 4 degrees Celsius it shall be this, and at 20 degrees Celsius it shall be given by 0.2975 divided by d in centimeter. And we shall see some other empirical formula regarding capillarity. By using Terzaghi and Peck's formula, that is Hc is equal to C by E d10, we can find the answer for capillary rise or fall. So C is nothing but the constant depending on the soil condition divided by E into d10. E is void ratio and d10 is the effective grain size. And here d10 shall be in centimeter only. Because these are some empirical formulas, we have to use only the proper sign. D10 should be in centimeter, so that we shall get the answer Hc in centimeter. And now let's move on to permeability. Permeability is nothing but Q is equal to Kia. Here K is the coefficient of permeability and Q is the discharge, and K into I into A. Here I is the hydraulic gradient. I is equal to del H by L. Del H means difference between the levels or difference between heights, and divided by L. L is the length of sample or length of the path. So Ki into A is the area of cross section. And now seepage velocity. Seepage velocity is Vs is equal to V by N, and V is nothing but the discharge velocity, and always Vs is greater than V. So you can see here N is porosity. N shall always be less than 1. So that's why Vs is greater than V. That is, seepage velocity is always greater than discharge velocity. And there is something called coefficient of percolation. So Kp is equal to K by N. So these are something related to seepage conditions. So first we have seen the effective stress formula. Then we have moved to capillarity and Terzaghi and Peck's capillarity formula. Then we have moved to permeability, seepage and coefficient of percolation. Now we shall see more about seepage also. So first we shall continue with the permeability, and then we shall move to seepage. And there are two things in permeability. One is constant head permeability, another is variable head permeability. Constant head is used when we are using sand or coarse grained soil, and when we use only the clay or very fine grained soil, we use the variable head permeability. So first let's see how constant head permeability affects the coefficient of permeability test. So K is equal to QL by AH. This is a basic formula. So we have already seen Q is equal to K into I into A. So that is modified into this formula. K is equal to Q into L into Q into L divided by AH. And in case of variable head permeability, that is in case of fine grained soil, that is clay and silt, we shall use this method to find coefficient of permeability value. And this will be given by K is equal to 2.303 AL by AT log base 10 H1 by H2. So what is A here? A is nothing but area of tube, area of that thin tube, capillary tube, and capital A is the area of soil sample, cross section area of soil sample, and T is the time taken from H1 to H2 drop, and L is the length. So 2.303 AL by 80 into log base 10 H1 by H2. So when H1 to H2 drop and H2 to H3 drop at same time T, then it shall follow a geometric progression. So H2 is equal to root of H1 into H3. So this is a kind of GP, that is a geometric progression when two heights are at the same time T, that is two drops, that is H1 to H2 and H2 to H3 are at the same time T. Then what will be the relation between these three head values, that is H2 is equal to root of H1 into H3. This is nothing but geometric progression. And there is another test called capillarity permeability test to find the value of K. So in this test there are some parameters like x1 x2, t1 t2, h0 h1, h0 at first stage and h0 at second stage, and hc is the capillarity. So in case of capillarity permeability test, this test shall be conducted in two stages under a head of some h0, 1 and h0, 2. So there are two stages. This formula is for first stage and this formula is for second stage. And this x1 and x2 are some distance in the first stage, that is the wetted surface moved from x1 to x2 distance. The wetted surface in the capillarity permeability test moved from x1 distance to x2 distance at time t1 to time t2. Similarly in second stage also. And what is S here? S is degree of saturation and N is the porosity value. And HC we know capillarity rise or fall, capillarity fall. And H0, 1. H0, 1 is the head. Actually this is the head at the stage 1 and this is the head at stage 2. So there are two stages in capillarity permeability test. Accordingly we have to calculate and we have to substitute all the things to get the answer for small k value. That is by solving both the equation we shall get the answer for small k, that is nothing but coefficient of permeability. So these are some tests like constant head permeability, variable head permeability and capillarity permeability test to determine the value of small k, that is coefficient of permeability, and the unit of permeability is meter per second or centimeter per second or like that, that is unit of velocity only. Now we shall see some other empirical formulas regarding coefficient of permeability. So first one is Karman-Cozney equation. So that is given by K is equal to 1 by C gamma W by nu E cube by 1 plus E d10 square. So what is C here? C is the shape factor or constant given by Karman-Cozney, and the gamma W we know unit weight of water, and nu is dynamic viscosity, E is nothing but void ratio, and d10 is effective grain size. And next Hazen equation, K is equal to C d10 square, and this is an empirical equation and we shall substitute all the parameters with respective units. For example, K should be in centimeters per second and d10 should be in centimeter, and C is nothing but Hazen constant and that will be ranging from 100 to 150, and this Hazen equation shall be applicable only for sandy strata or sand soil. And Loudon's equation is given by log of Ks square equal to A plus Bn. Here N is porosity but S is not degree of saturation. S is nothing but specific surface area and that shall be given by 6 by root AB, and AB are some constants regarding Loudon's equation. And Terzagh's equation shall be given by K is equal to 200 E square d10 square, and this also shall be in centimeter per second, that is K shall be in centimeter per second and d10 shall be in centimeter. And last consolidation equation, K is equal to CV gamma W mv. Here CV is coefficient of consolidation. So consolidation so discussed in the previous video also, you can refer to that videos to get an idea of all the formulas regarding CV, that is consolidation formulas. So CV into gamma W into mv. Mv is coefficient of volume compressibility. This is also dealt in the previous video. So these are 5 important and major empirical formulas regarding coefficient of permeability. But consolidation equation is not an empirical formula. uh, this formula satisfies the dimensional formula, so this is not empirical. But Karman-Cozney, Allen Hazen, Loudon's and Terzaghi sequence are empirical formulas regarding permeability. Now we shall see some other things regarding permeability also. Coefficient of absolute permeability is nothing but K naught is equal to K into nu by gamma W. So if we remove or if we multiply the actual coefficient of permeability with nu and gamma W, we get a value of K naught, that is nothing but absolute permeability. So what does it mean is absolute permeability does not depend on viscosity of water and the unit weight of water. So we have to understand the difference between coefficient of permeability and coefficient of absolute permeability. So absolute permeability does not depend on dynamic viscosity of the liquid flowing in the soil strata and also the unit weight of that liquid. That is here nothing but water we have considered. So that's why absolute permeability has the unit of meter square or centimeter square, anything, or we can say Darcy. So 1 Darcy is given by 0.987 into 10 power minus 8 centimeter square. So this is a unit of area, similar to area units. So 1 Darcy is equal to 0.987 into 10 power minus 8 centimeter square. So this is the coefficient of absolute permeability, and this does not depend on dynamic viscosity and unit weight of water. So that's why we are multiplying actual permeability by nu to nu and gamma W, nu by gamma W. And there is something called equilibrium permeability, equivalent permeability with respect to horizontal flow and vertical flow. In case of horizontal flow, what will be that? So KH is equal to summation of KH divided by summation of H. So this is the horizontal flow and this is the vertical flow. So in case of vertical flow, what will be the coefficient of equivalent or we can say equilibrium coefficient of permeability? So that is Kv is equal to total height of soil strata divided by h1 by k1 plus h2 by k2 plus h3 by k3 and so on. And when comparing both the values, always horizontal flow is greater than the vertical flow, because in horizontal flow the hydraulic gradient will be constant. Hydraulic gradient will be constant, but discharge will be added, q1 plus q2 plus q3 like that. In vertical flow, hydraulic gradient is not constant. I is equal to I1 plus I2 plus I3 will be there, but flow will be constant. Here also Q, here also Q, here also Q. So that's why horizontal flow has higher permeability than vertical flow. Now we shall move on to seepage chapter and what are the formulas under which we have to study. So first we shall see the seepage pressure. Small ps, that is p suffix x, is equal to I into z into gamma w. So what is I? We know that is hydraulic gradient, and z is the depth of the strata, and gamma w is unit weight of water, and capital Ps is seepage force of seepage, and that's why we are multiplying this formula with area also. That's why V is volume. So I into volume into gamma W. And specific seepage force is given by I into gamma W simply. So that is specific seepage force is nothing but the seepage pressure per unit height. So that's why that's why PS divided by Z, that gives the PSS, nothing but I into gamma W. So these are some important terms and important formulas regarding seepage. And sigma bar dash is nothing but the effective stress along with the seepage pressure. So how to calculate that? So effective stress plus or minus small ps. So what is why plus or minus? Because of seepage can be in upward direction or downward direction. In case of downward direction, we have to plus. In case of upward direction seepage, we have to minus. So that's why sigma bar plus or minus ps. So in case of seepage, what will be the effective stress? So that's why sigma dash bar. And quicksand condition is a condition under which IC, that is critical hydraulic gradient is given by g minus 1 by 1 plus e, or we can say g minus 1 into 1 minus n, or gamma submerged divided by gamma w. So this is how we have to calculate the IC, that is a critical hydraulic gradient, and by using this we shall find FOS, that is factor of safety, is equal to IC by actual gradient. So FOS shall be 2 to 3 to avoid quicksand condition. Now we shall see the formulas regarding flow net. In case of isotropic medium, del H is equal to H by Nd, and Q, that is discharge, is equal to K into H into Nf by Nd. So what actually is the Nf? Nf is the number of flow paths. So 1, 2, 3. So these are the flow paths, and number of flow paths is given as Nf. And Nd is the number of equipotential drops. So how many drops are there? That is nothing but Nd. And K we know, coefficient of permeability, and H is the height or the level difference. So del H is equal to H by Nd. Nd is nothing but number of potential drops. And in case of non-isotropic medium, we have to transform that section by using this relation. So what is the transformed section? Xt is equal to x into root of ky by kx. Kx is nothing but permeability in x direction, and ky is in y direction, that is vertical or permeability, this is horizontal permeability. In case of non-isotropic medium, we have to transform that section by using this relation xt. And there is another formula regarding seepage pressure by using Nd value. So H minus Nd del H into gamma W. H minus Nd del H, that is nothing but Nd into del H. So on getting this to the right hand side, so H minus Nd del H into gamma W gives the answer for seepage pressure. And in case of non-homogeneous section, so what shall be the permeability change? So K1 by K2 is equal to tan alpha 1 by tan alpha 2. So alpha 1, alpha 2 are the angle due to non-homogeneous section. And we have to prevent piping by providing filter. There are many ways of prevention of pipe. One of the ways is providing filter. So in case of using filter, what are the criteria? So D15 filter is divided by D85 medium shall be less than 5. What does it mean? D15 size, or so D15 means the size about which the 15% is finer than that. Similarly, 85% is finer than that is the D85 size. So D15 of filter divided by D85 of medium shall be less than 5, and D15 of filter to D15 of medium ranges from 4 to 20, and D50 of filter to D50 of medium shall be less than 25. So these are some criteria regarding filter to prevent piping failure. So we have seen the formulas regarding permeability and seepage. Now we shall move to the last section, stress distribution of soil. So there are two things, Bosniak's equation and Westergaard's equation. We shall see both the things. So first, Bosniak equation. So sigma z is equal to kb q by z square. So what is kb? Kb is the Bosniak coefficient, and kb is given by 3 by 2 pi into 1 plus into 1 by 1 plus r by z the whole square power 5 by 2. And at r is equal to 0, so that is nothing but the maximum stress, that is directly at the point load. So at that point r is equal to 0, and that shall be given as sigma z equal to 0.4775 q by z square, and this is the maximum stress, vertical stress. And this is the shear stress due to that sigma z, and shear stress is given by sigma z into r by z. So here you can see this is due to vertical plane. This formula is regarding horizontal plane, and this diagram is regarding vertical plane. For vertical line or vertical plane, r by is equal to r by z is equal to 2 by 3 root equal to tan beta, and here beta is this angle, and at this angle sigma z will be maximum, and at this maximum sigma z, r by z shall be root of 2 by 3, of vertical stress distribution. So you can see here, so this is the horizontal distribution, how horizontal distribution varies, and this diagram is for vertical distribution. And now let's see the Westergaard's theory. Here Westergaard's theory uses the Poisson's ratio value, and Poisson's ratio is nothing but the lateral strain by longitudinal strain, and that shall be equal to 0, and because of this Young's modulus is infinity. When Poisson's ratio is 0, Young's modulus is infinity, and sigma z is equal to kw into q by z square, and kw is calculated by using this formula. There in Poisson's theory we have kb value 3 by 2 pi 1 by 1 plus r by z the whole square power 5 by 2. Here kw value is given by this 1 by pi into 1 by 1 plus 2 into r by z the whole square power 3 by 2. And sigma z is equal to at maximum stress, that is r is equal to 0. At r is equal to 0, what is sigma z value? Sigma z is equal to 0.3183 q by z squared. So here you can see clearly the diagram. This bell shaped diagram is for Bosniak's theory, and this curve is for Westergaard's theory. And at somewhere between r by z is equal to 1.52, both the stress value attains the same, that is intersects one and the same. That is nothing but at r by z 1.52, both theories are equal. Now we shall see some other loading case regarding vertical stress. So due to uniform line load, that is like this, due to uniform line load, sigma z equal to 2q by pi z into 1 by 1 plus x by z the whole square power square. So this is the formula regarding uniform line load. And in case of uniformly loaded circular area, what will be the sigma z? So 1 minus cos cube alpha into q. Cos alpha is equal to z by root of r square plus z square. So we know what is r. R is the radius of the circular area, and z is the depth at which we have to find the value of sigma z. And in case of strip load, this is a kind of strip load condition, q by pi into theta plus sine theta cos beta. So this is beta value, and the angle made with 2 points at point O, that is nothing but theta, or we can say alpha, anything. And at the center of the strip load, beta is 0, so cos 0 is 1. So simply we can say sigma z is equal to q by pi into theta plus sine theta at what? At the center of the strip load. And this is the Newmark's equation, and here we have to find the value of k by using this relation, this big relation. So k is equal to 1 by 4 pi into something regarding m and n, and m is nothing but L by z, and n is equal to b by z. So this is the Newmark's equation, k into q. Now we shall see the Newmark's chart, how it is calculated. So by using Newmark's chart, we have to calculate sigma z equal to k into q by z square, and I is the influence factor, and here I is equal to 1 by m into n. We know already what is m and n. M is L by z and n is b by z. And here sigma z is equal to I into n into q. Here I is given by 1 by m cross n, that is influence factor. Basically influence value shall be 0.005. Here you can see in this diagram, and into n is the number of circles, into q. So these are the some basic and important things regarding stress distribution. So in this video we have learned the formulas from permeability, seepage and stress distribution. Thank you for watching.